In this video, we're going to use our graphing calculator to model quadratic data and also use it to help us answer some interesting questions about that data once we have it graphed. I'm using the same example that they have in your textbook on page 308, and it goes something like this. A study compared the speed x in miles per hour and the average fuel economy y in miles per gallon for cars. The results are shown in the table below. Find a quadratic model in standard form for the data, then use your calculator's max and min feature to find the speed at which optimizes fuel economy. So we have our data here. What we're going to do is let our calculator kind of do the hard work for us, and just like when we did a linear regression, we're going to bring up our calculator, and if you hit the stat button, you hit the stat button and choose number 1, edit. That should bring up your list, L1, L2, L3, and so on. L1 is where we plug in our x values, L2 is our y values. Now if you look at the x values, we go from 15 to 70 and we count by 5s. So I'm just going to go ahead and start typing these in. So it's 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and 70. Now, list 2 is the corresponding fuel economy in miles per gallon. So when we're going to 15 miles per hour, the miles per gallon was 22.3. The next one is 25.5. Then we have 27.5, and then 29.0, 28.8, 30.0, and then we dip down to 29.9, then we have 30.2, 30.4, 28.8, 27.4, and 25.3, going 70. Now one thing I'm going to do before I do anything is make sure that I have the same number of L1 and L2 values, and it looks like I do. I have 70 and 25.3, and that matches my table, so I know we're good to go. From here, what you're going to want to do is hit the stat button once again, but now you have to cursor over to the calculate menu and choose quadratic. That's quadratic regression. So you can either hit number 5 or cursor down and choose number 5 and hit enter. And in this calculator, I can just hit enter twice and it knows to use L1 and L2, and it spits out these numbers for me. Now, in real life, you're not going to get very nice values for A, B, and C, but what we have right now, if we write it down to the nearest hundredth, I'm going to write it on the screen for us. I get y equals negative 0.0. Now, if you round this to the nearest hundredth, it would be negative 0.01 x squared plus 0.75, if we round it, 0.75x, and then plus the c value of, what was it, 13.47. So I'm going to have 13.47. Geez, I had all kind of room and I kind of ran out. So this is our model. Now what I'm going to do is use that and plug it back into my calculator to help us solve the second part, which is, all right, what's going to be the optimal speed to maximize fuel economy. So what we're going to do is this. Now when I go back, I'm going to lose that. Hopefully you wrote down that equation. I am going to go back to my calculator and I'm going to hit y equals. Let's go back to y equals, and I'm going to type in the calculator the quadratic function. I think it was negative 0.01 x squared. Then it was plus 0.75 x plus 13.47. Now, if I just graph this, I may not know if it fits the data very well. And it's kind of nice if we can just put the scatter plot up with the actual parabola so we can see how nicely it fits the data. To do that, it's pretty easy. All I want you to do is hit second, then the y equals button, and that takes you to your stat plots menu. You can set up many plots, but we're just going to stick with that first one. Just hit enter, please. If you hit enter, it'll take you to this screen. Please turn your plot on by cursoring on and hitting enter, and you should have on highlighted. Then your type you can leave as a scatter plot, that first option. X-list and Y-list should be L1 and L2, and we will mark it as is. That's all you need to do. So if you go to y equals, you'll notice the y1 has the equal sign darkened, and now plot 1 is highlighted. That's going to plot the data and our equation at the same time. Now, if we just go to zoom 6, this is what you're going to see. This is the standard window. Keep in mind, we don't have any x values that are negative. All the x values go from 15 to 70. So let's go to their window. And our x min, let's go from -5, so I can see the y-axis. And our x max, the largest x value you have is 70. I'm going to go a little bit past that. Let's go to, I don't know, 75. And let's count by 5s. That should be fine. Y min, let's go just to -5. What's our largest y value? Largest y value is like 30.4. So I'm going to change this to maybe 35 to make sure we go a little bit higher than it. The reason why I'm using a -5 for my y min is so that I can see the x-axis. I want to go a little bit underneath it. And let's scale the y-axis and count by 5s. Hopefully if we hit graph, we'll see a decent picture of the scatter plot and our parabola. Now this is interesting. When you graph it on that window, you should see the following. All those little points represent the scatter plot, the actual real-life data. And if you look at our parabola, it doesn't look very good. Actually, it doesn't really go through much of the data, so that concerns me. I wonder if we did something wrong. I'm going to go to y equals and just double-check what I had. I thought we did agree it was going to be -0.01x squared plus 0.75x plus 30. I think I did everything right. The thing is, maybe I need to really be a little bit more careful about my accuracy. So if you recall the original problem, if I quit out, I had -0.008 for my a value, and that's the most important value, that leading coefficient. I'm going to change that to be -0.008. So I'm going to go -0.00. Let me insert, I'm going to hit second and delete to insert another 0 and change that 1 into an 8. And let's see how that works. I'm going to graph it again. Now that parabola looks really pretty good. It's going through most of the data, and it's a model for it. Now what I'm going to do is I'm going to try to use the max and min feature to find the best spot for fuel economy. And what I mean by that is this. This is kind of like back in the first section. Remember, the y-axis here, this is fuel economy. And we want the best fuel economy. So the highest fuel economy occurs right up here somewhere. And you remember, hopefully, that that special point is the vertex. We want to find the vertex. Your calculator can find the vertex for you if you use the max or min feature. In this case, we don't want to find the minimum value, we want to find the maximum value. So if it's a parabola that opens, and I'm going to write this maybe one time, if the parabola you graph looks like this, and you want to find the vertex, this is the maximum. That's like the highest point on the graph. If we were graphing a model that happened to go like this, let's say, and we wanted to know what that point is there, that vertex, we would want to use the minimum feature because that's the lowest value or the lowest point on the graph. Unfortunately, everything that I just wrote is going to go away in a second when I show you this, so I hope you have that written down. So I'm going to go back to the calculator here, go back to my graph, and this is what you do. You're going to hit second and trace. This is a menu we've used before. I want to calculate the maximum. So that's 4. Cursor down to 4. Hit enter. And all you have to do is make sure you click somewhere to the left of the vertex. So right now the cursor's flashing definitely to the left of the vertex. You could even go further to the left. Hit enter. And then you're going to make sure you go past the vertex to the right. And I'm just hitting the right arrow many, many times. And you can see my cursor go past the vertex. I'm on the other side of the hill, so to speak, going downwards. I'm to the right of the vertex. Hit enter. When you guess, you have to guess in between those two values. So I'm going to put my cursor somewhere where I think the vertex is. And it spits out the maximum, which is the vertex. If you take a look at that, that's telling me the vertex. The vertex is at the coordinate 46.875. Oops, I wanted to put comma 31.05. I'm just going to round that. Remember, this is my speed, and this is my fuel economy. This is, according to the model, my best fuel economy. So the speed that gives me the best fuel economy, if we just round to the nearest mile per hour, looks like it's about 47 miles per hour, maximizes my fuel economy at 31.05 miles per gallon. So kind of cool. We can be pretty precise about this using our graphing calculator. We'll practice a couple more tomorrow in class. Thanks for watching.